darf ganz herzlich begrüßen zu der heutigen offenen Runde von Architects for Future hier in Zürich. Mein Name ist Hans. Ich werde das heute Abend moderieren. Tonight, Jan-Lee Landru is joining us to give a short input lecture on his work of loam-based concrete and his startup Oxara. Jan-Lee Landru is a PhD from ETH. So Dr. Jan-Lee Landru has taken his research that he wrote his PhD on and worked it into a spin-off. I'm not even sure how many years now you're working already on your spin-off, but I think you're step by step gaining ground and have much interesting to tell about your research and your first projects regarding your company. Jan-Lee, we're really happy to have you here tonight. We're all very excited and are looking forward what you're going to tell us about Oxara in the next couple of minutes. Yeah. So you have the word.
Thank you very much, Hans, and thank you for the invitation. Thank you for the introduction also. So I will really jump into it about Oxara and the meaning of Oxara, because it kind of plays a huge role for what we are doing. Oxara means community, and it's from my mother tongue. And I think working with Earth, we need to have this sense of community. We need to have this sense of working together. So we are a spin-off from ETH, co-founded in 2019. So it's been 1 year now. But beforehand, I did my PhD, as Hans mentioned, on the topic of cement-free concrete. So that's the subject I will talk about today. And this cement-free concrete is what we call Cleancrete, clay earth concrete, or a better, like a Cleancrete. And we believe it's a sustainable or a solution toward a sustainable construction industry. And here I would like to draw your attention to the to this picture, because you can see, like, on the same picture, on the same city, town, like two different aspects. On one side, you have like informal settlement, where there is a huge need for affordable housing. And on the other side, you see kind of a more modern construction with concrete, where we might say the need here is more sustainable product, more sustainable product. And we believe that the Cleancrete is a solution for both of this world. So without surprise, I think you all know how concrete is produced. Is a mix of gravel, cement, sand, water, and admixture that you bring in a construction site or in a construction plant. You mix it and then you deliver the concrete either on a ready-mix concrete or prefabricated element. What is not so well documented or evaluated is the amount of excavation material that is landfill while doing so. The excavation material is the material you take out from the ground while doing the foundation or producing the tunnel and so. And this amount of material represents in Europe around 45% of construction waste, and in ton it's around 400 million tons of excavation material.
Sorry, Jan-Lee, can I just have a quick interruption? Sorry, could we ask all people to mute their phones, please, their microphones? We're having an echo. We really appreciate it. Thanks so much. Sorry, Jan-Lee.
No problem. So yeah, we are talking here about more than 40 million tons of excavation material landfill each year from what we got from documentation. And there are some countries that doesn't provide such information. So it's an important amount of resources locally available that is currently wasted. And the idea of Oxara, which was carried out during my PhD, was how do you use this waste and transform it into a more sustainable building product? so we have developed then a mineral admixture that allows to process the excavation material like conventional concrete using similar concrete infrastructure and processes. That means that you are able to mix it in a concrete mixer, it's fluid, and then you are able to cast it, remove the formwork within 1 or 2 days, and you can use it for low-rise construction, 2 or 3-story houses, or for non-structural element, as you can see here. Therefore, create a closed-loop system. So what does it mean concretely? Here's a small video of the process. So here you have a excavation material, you add water, and you have our admixture here that you add to it, within a range of 1 to 2% maximum. And you mix it like conventional concrete. The material is fluid enough to be casted or vibrated. The advantage is that because there's no cement, as we are trying to do a cement-free product, you can work with it without wearing gloves because there's no aggressivity or alkalinity of the material. And in this case, 24 hours later, we are able to demold the formwork. So this process was done at the end of my PhD to validate whether or not our admixture technology worked, which I did my PhD on, and if it worked with a different sort of excavation material that one could take in the area of Zurich. So later on, the goal was to test on a little bit bigger scale how this product will work and to estimate the CO2 impact. And this was done in 2019, was our first scale demonstration. So it was a 1.5 meter height, 30 centimeter, and was cast and demolded after 1 day. And we did some LC analysis, and then we realized that the CO2 emitted by the embodied energy, the embodied CO2 is around 12 kilograms of CO2. While if you take normal concrete, we are talking here about around 300 kilograms of CO2 per cubic meter. Therefore, we estimate a CO2 reduction of 90%. Keep in mind that our material is not, in terms of performance, not comparable to concrete, as we are talking here, material with a similar performance as a rammed earth product. And we went on to do also some different demonstration. This one was done also toward the end of my PhD with in situ biobureau architecture. And the goal was to use it as a screed and see how the material would perform. And if could it be used for such application or not. And now we are interested to further develop it and try to see how to implement it in the market. Another project that we did also was with Philip Block Research Group at ETH. And the goal here is to combine low performance concrete with a high-tech design, taking into account the material property, but focusing on the design of the arch, here kind of a arch structure for a floor application. And on this floor slab that a group of 2 persons can carry each part, we kind of post-tension it with this cable, and we are trying to evaluate how much strength load the floor can take. And we are able to put around 250 kilos on this unique kind of part of the floor. And our goal is to produce more, to put them together to create a whole, a full floor system. And it's currently being developed now with the PhD student and the master, the postdoc student, the postdoc. So hopefully in 2021, the first, next month we will be casting it. So we hope that we could have a positive result. Another successful demonstration we did was a wall application, a 3-meter tall wall, 25 centimeter thick element. And in this case was done with, in Switzerland or in Zurich, people might know, Keybag, a recycling company, and Marty, a construction company. So we used their waste material, and we mix at their place and transport the product to ETH, where we are based, and cast it on in a normal formwork. And 2 days later, the formwork was removed, basically. So which shows that the process is more or less similar as concrete. And one advantage is that we are able to reduce the thickness of a rammed, like compared to a rammed earth wall, as here we are working at 25 centimeter thick. The issue that we had here was the slow drying process of the wall, because we had quite huge fluidity. We didn't need to vibrate actually the mix. Therefore, it took quite a long time to dry. So to further develop this technology, now we are trying to, we started already end of last year, but we produce different elements that will combine together to create kind of a pavilion, and see how this pavilion we can bring them together by developing like a joint system. As you can see here, is it circular? Is it triangular? That might need it. We are not sure yet, but we are trying or testing different technical solutions to be able to see, in case of prefabrication, how do you assemble your element. As I was mentioning, the cast wall that we did, we saw that we had some drying issues. Therefore, we were considering how to reinforce the structure with steel or wood, for instance. And we start a project with the Grammacio Color Research Group and 2 master students who are part of the MIS DFAB program in 2020. In this case, Jumana and Indra. And they proposed to move forward with a Cleancrete mesh mold, where the mesh is a bamboo structure to the 2D slices that afterwards joined together with a rattan wood pieces here, and the earth material is cast in between. It should flow, the earth should flow enough so that it covers it shouldn't flow too much so that it covers barely the mesh mold, the mesh, and then afterwards you can like repair the surface, so you created this smooth finish. And here's a kind of a video of the process that the student did. So it was a collaboration between Oxara, the Grammacio and Color Research Group. The really interesting part here was that the robot was kind of a manual process. And because we are using bamboo, they figure out that a heat gun is well suited to create the shape that is needed. And they use a tie gun, of course, to join all the elements afterward together. And there's a huge care also about the bamboo piece stick between, as it's also used as a leveling how far your material should flow outside of the mesh. So once the bamboo mesh was created, Then we use, in this case, sludge instead of excavation material. So the sludge is defined after washing sand and gravel. So to have a consistent mix, and we use the sludge. To it, we add some sand and some fibers. What we observe here is that, yeah, the formulation was not necessarily perfect, as it was hardening quite fast. However, it was still good enough to fill in the form and afterward to do the finishing. This took kind of 2-3 hours to be done. The casting, I would say. And now the goal is to continue further on the project, as we want now to see how to implement it on a real scale. Therefore, we will move to a more straight wall element. Instead of bamboo, the goal will be to try to use wood, for instance, to see how we can cast within a wood frame, and if the adhesion or the cohesion will be the same. And the other aspect is how do you connect it in a building element. Therefore, we are trying, if you have a concrete wall, existing concrete wall, and then you have a prefabricated element, how would you connect it? Or how would you create your wall element so that it fits your building construction process? And another question that we often have is how do you create door and opening, considering that the material is fluid and you might have some shrinkage and some settlement issues. So this will be done also beginning, the project will start beginning of February, hopefully, and we will investigate that with one of our partners currently we are talking. Another project of us or product of us is the brick. It's kind of different than conventional bricks that are like a compressed earth brick. Here it's fluid casted in a normal mold and removed after 1 day or 2 days as for the normal concrete process. And this brick have 10 megapascal, which is quite a good property for a brick without firing it. And our goal now is to try to see a producer of such a brick to be implemented at an industrial scale. I don't have much to share about it because most of the interest is toward the Cleancrete. Therefore, we have quite developed the Cleancrete. Whereas for the brick, our goal now is to find the industrial partner. Now, if we are talking about how sustainable our technology is, I think one needs to understand what is the material flow in Switzerland, in the case of Switzerland. And here is a model that we have developed last year with the BAFU. Here's the building stock or the material stock of building in Switzerland. And here you have the input of material, how much million ton of material is used annually, more or less. It's around 60 million ton of material coming in. And the amount of excavation material that goes out and landfill. And you can see that is around 52 million ton, more or less similar amount of material goes in and goes out. The material that's come from its gravel, sand, cement, and other material. And here we differentiate between concrete for structural application and concrete for non-structural application. And now we start computing if we add Cleancrete or we replace 20% of concrete non-structural with Cleancrete. And what we see here is the amount of resource therefore needed for input decrease as you are using more and more excavation. If you want to see here, we have 53 and here 2 million ton, whereas here we have now 9.7 million tons of excavation material. And the other important aspect is the CO2 that is emitted here. So we could see that we have not so much CO2 emitted on a global scale. And if you go further and then you substitute Cleancrete by 50% or concrete by 50% of Cleancrete, what amount of CO2 and resources you are able to save. So this gives you an idea how sustainable our product is and how much novel resources we are able to save, considering the replacement we are able to generate. So and then we did a similar thing on an EU scale, where we estimate that 300 million cubic meters of concrete is produced in Europe, and which emit around 90 million tons of CO2 per year. And considering that you have 350 million tons of excavation material per year in Europe, 5% conversion of the excavation material into Cleancrete will reduce around 30 million tons of aggregate or sand extracted per year, which is a huge amount that we are contributing to save. But also 10 million tons of CO2 will be reduced by using Cleancrete. And we hope that by 2030, we are able to achieve this goal, as that's what we put as a target for Oxara. And I hope that I managed to convince you that, yeah, our admixture and the final product, Cleancrete and cleanbrick, could help solve world issue, either it's sustainable housing or affordable housing. And I would like to end with who we are as or what we are trying to achieve, basically. What we understood from the construction industry is that you have different players that operate together but are not connected or not always talking to each other. And what we are trying to do is to bring them to a level where they are able to speak to each other. Meaning that as we are trying to implement new technologies, we need the approval of not only the owner to use it, but we need to have the consent of the architect who understand the material property and behavior so that the design is done accordingly. We need to work with the construction company who knows how to use the material on the construction site, but also the recycling company so that he understands how to mix our product or how to produce it. So we cannot just be able, like, be talking to a concrete manufacturer or brick manufacturer and forget the other stakeholder, but we need to put them all together so that we redefine the construction industry, and then we build a strong, sustainable ecosystem with the different stakeholders in order to achieve sustainable, affordable housing for all. And another important thing is we are currently 9 people, me, myself, and my co-founder Thibaut Demoulin. And we are also supported by experienced business guy and an architect who has experience in the construction industry, working with concrete, but also with earth construction material. And we are now joined by 2 new civil engineer that will help us define the technical solution and validate the performance of our Cleancrete and cleanbrick product for industrial application. So I like this quote from Nelson Mandela, because after my PhD, I thought that I have done the best I could do, but I have achieved what I could achieve, but I have realized that no, after climbing a great hill, one only finds that there are many more hills to climb. And our next step or hurdle we need to climb is start implementing the project on an industrial scale that we are now discussing with the structural engineering office construction company and recycling company. Unfortunately, I couldn't share more about specifically those projects because, because of confident, I didn't have the approval to do that. But on that note, I have finished and I'm waiting for your questions.
Janli, thank you so much. It was really interesting. I'm really excited. I think there's great things ahead for Oxara. As we do it here normally, I would like to invite everybody to pose questions to Janli, right? I will hold back. If you could maybe turn on your video for the question, it would be great, so I can see you. And then we would just go, say, in order of how the questions come in. I'm happy to ask myself, but I don't want that privilege. So are there any questions for Nyanli and his work with Oxara? I don't see yet someone turning on their video. Maybe Nyanli, before we get a first question, I have one myself. As I don't see one, I'll ask myself. Could you just elaborate a little bit more about the last picture? In the last picture, maybe can you turn the last picture on again?
Yeah.
That be possible?
Yes, this one.
Yes, exactly. Can you just maybe elaborate a little bit about what we're looking at? I assume parts of it or everything, I don't know, is from Oxara, but can you tell us? I guess most people here are architects. I'd like to know, what am I looking at? Is this a Unterboden? Are these, I don't know, floor tiles for a bathroom? Is this all from Oxara? Can you tell a bit what these are?
So I think the attention here, it's more on the floor element. So the screed, I think it's a screed in English, that you could use like a material for filling the floor, and then afterward you come with your final layer, either some stone plates or wood plates that you have to for the finish. The goal here was to evaluate where the performance of the material is not so much required, but the mass is needed for either like acoustic or thermal behavior. So, and it was done to. It was also a project with In Situ Baubureau, and now the straw bale frame was again for their project, how do you use most waste material for construction, but the part done by Oxara is mostly the floor element here.
Okay. Have you built this somewhere already, or is this still a test?
So it's still a test, and we are now discussing on a project in Basel for implementing it.
Very nice, very nice. Nyanli, we have a question from the chat. So Ray is asking, what fields of application do you see in particular for Oxara's technology?
So that's a good question. For ourselves, we are always trying to identify what is the easy application that solve most of the problem. The first one we saw is like product that have low risk of development or small risk of development and high potential. So the brick, for instance, is one good application for non-structural element, facade application, or interior wall, and things like that. So we are now trying to put our focus more on the brick application, And next week, for instance, we will we'll visit a company for a large-scale test. But at the end, the application, we have seen that it's depending on the architect, how he wants to use it. We are mostly directed by the architect and the civil engineer. We see an application for non-structural application, but still, we are not sure if it's the best way to go.
Very good, thank you, Nyanli. We have two more questions from the chat. Wurde schon Cleancrete als Unterboden mit Bodenheizung getestet oder angedacht? Is there a possibility of combining Cleancrete with a floor element and combine this floor element with a floor heating?
Yeah. So yeah, for the application we are testing in Basel will be combined with the heating solution.
Fantastic. So the answer is yes.
Yeah. No, yeah, it will be. Now the question is how one need to check the dilatation of the material once you have heating system included. But I think this could be solved with the thickness of the floor element.
Yeah. Could you talk more about that project in Basel, or is that also still in planning or confidential?
I cannot say the name of the partners. However, I think it's a project that includes the development of a sustainable, fully sustainable circular building. So a lot of waste material will be used. And one of the challenge was how to remove most most concrete, and it's planned for 2022, and we are now in the testing phase.
So meaning at the end of next year, we could expect you telling us about that project in more detail.
Yes, I hope that at the beginning of next year, we have already one or two product apply in real construction.
Okay, fantastic. And just a question. So, and in this Basel project, you're just doing the floor thing or also other elements?
No, in this Basel project, we'll be doing mostly the floor, and the wall element is not yet approved. So,
yeah. Approved by whom?
So the engineering office need to validate the performance. Yeah.
Okay, very good. We have another question from the chat. So the question is, what about compressive strength of the concrete, also in comparison to ordinary concrete?
Yeah.
Martin Wirtz is asking.
Okay, yeah. So basically our material is mostly similar to conventional rammed earth. We are able to have a performance between 2 to 4 megapascal. However, because it's fluid and you are able to cast it in a more smaller, like the thickness could be much more smaller than a normal rammed earth, basically. And then we are now trying to assess the thermal conductivity, but also other characteristics like thermal expansion, the creep behavior and so. But in terms of megapascal, is a 2 to 4, and normal concrete you are between 20 to 30.
Okay. So maybe I can just have a little bit of follow-up question, which I'm not an engineer, so I think I don't have a deeper understanding of this, but what's the consequence of those different properties? Can you build structural walls? And if yes, then for how many floors?
Yeah.
If I just try to imagine what that can.
Yeah. Normal 2-3-story house, it's in terms of, if you are calculating just the dead load, the load that is needed for the wall to be self-supporting, it's around 0.5 0.75 megapascal. And so meaning that you are able to build 2 3-story house with our product. However, because of safety factor, you need to put a certain safety factor into place. For concrete, with the 20 megapascal, you know that you have you can then reduce your safety factor. Therefore, you are able to have a more static element. And in our case, you have a high safety factor because you are really close to the performance of your like the dead load of your material. So meaning that even though you are able to build 2 3-story housing, you need to have structural planning. How do you do it efficiently? I think it's the same as a normal rammed earth construction. It's not just by ramming you are able to build a 2 3-story house, but by careful design of where your wall should be and how your wall should be and the thickness of this wall.
Would that mean, just as a comparison, your material somehow compares to rammed earth performance-wise?
Yes.
Yeah. So if I know a rammed earth building, your material could perform in a similar way. Is that an assumption that's fair?
Yes.
Okay, very good. We're getting a lot of questions in the chat. Ray is asking, is the material water resistant or can it be compared to rammed earth? Let's actually, let's ask the first one first. Is the material water resistant?
We have different admixture and certain admixture make the material water resistant. So we have Cleancrete that are not water resistant, like a conventional rammed earth, not to say. And now we have been developing more water stable Cleancrete, and we'll be testing it as well the coming years. However, like the main difference is the processing. In our case, it's casted. Like by cast, I mean it's poured like a normal concrete. You don't have to ram it. And rammed earth, like we understand the process in terms of you need to ram each layers. You need either like intensive like labors and also man required. But in our case, it's just with a concrete truck, you bring the material and then you pour it in a formwork like a normal concrete.
Raffaele, Giovanni, you have another question.
My question is Oxara the only one in the world in developing Cleancrete, or are there others in other lands, and are you connected?
So Oxara is not the only one developing poured earth. However, what I have seen in literature outside is most of the poured earth use cement, like either 5 to 10% cement, to be able to have a fluid mix and so. But not mixture that make the earth fluid and make it hard. It's the things that we have as kind of our IP, our intellectual property, and so far we are mostly the only one doing it. Other companies like in France, the Green Hoffman Cement produce poured earth but with cement. Materop has a technology that apparently make the earth as strong as concrete, but apparently it also has cement inside. But they have an IP on it, and we don't know what kind of technology it is. In India, for instance, you have at Auroville, they have been developing poured earth as well with 8% cement, 4% lime. Like there are technologies, but we are the one that does it completely without cement.
Okay, so you are pure.
Yeah, like our material can afterward be reused without any worry about environment, but also the putting energy to process it.
Thank you very much, Rafi, for the question, and Janli for the answer. We're having here in the chat more of a comment by Jordan.
Yeah, it's not a question. It's yeah. From my point of view, we don't have to compare the Cleancrete with concrete or other product that we are using at the moment, but this is the possibility to rethink the way that we're planning or building. Like with we don't have to build our houses with wood instead of concrete. We have to think new solution. Like with the car, we don't have to replacing petrol car with the electric car. We have to rethink the way we are using the car. Yeah.
Oh yes, I think, and it's really important to know that to differentiate between our product will be a replacement of concrete. Also, what we are trying to say here is there's a lot of product in a building that doesn't necessarily require concrete.
Yeah.
And if you start thinking like, where could you use non-concrete product, then you can still have concrete in your house, but in certain specific elements can just be non-concrete, because you don't need to carry heavy loads. You don't need to have similar, like always concrete performances. So that's where the approach can be found, like could be interesting. Or there are a lot of things that we do that we don't necessarily have to do it with concrete. So is Cleancrete or cleanbricks or other sustainable product being like a substitute? Yes, and why don't we use it? I think that would be, I completely agree with you, Jordan.
Thank you, Jordan, for the interesting comment, and Nyanli for the answer. I see Rafi has a question, but we have some questions in the chat before, so I just go in order. Nabil El Shami from Berlin. The question, Nyanli, is, are you willing to tell us more about your secret ingredient? What is the white powder? Is it cellulose?
So the white powder is not cellulose. However, I cannot tell you the composition, but what I could say is mineral that you found directly either from the ground. Actually, you found it on the earth, and then you can just extract it and purify it. And that's our technology. How do you make it pure so that you can bring it back to the earth again? And it's now a blend of different powders that one need to be careful. How do you create it? The mixing is quite important. Yeah, and now we are also looking to bringing other type of waste type of material to be able to make it even or bio-based material to make it even more interesting, as we are thinking of how do you reduce the shrinkage, how do you improve more the water stability, how do you make it resistant to, if you are adding wood, for instance, how do you reduce them or improve the resistance to like moisture absorption and so. So it's in this case also a new type of chemistry that we are working on.
Thanks, Nyanli. I think the next question, Stefan und Jan an alle also asked, was wird als Bindemittel genutzt bei Cleancrete? I think that's in the same, let's say.
Yeah, it's the same question. Thank you.
We're having a lot of interest in the white powder.
Yeah.
But we understand that you cannot tell us everything.
Like what is interesting is we work with it without mask and hand gloves and so. And for us, it's really important. It's non-toxic. It's safe, and we are not killing a dead species or like extinct. We are not exploiting a resource that is going under extinction or getting scarce and things like that. But we often try to see also like what is the resource availability. For instance, in Europe, we know that now we know that there are some companies that are able to prepare some of the components better than us. So we are trying to see how they are preparing it, and is it more sustainable than what we have to, what we do. And then we are the one who knows what are the different ingredients and how do we blend it together.
Raffaele, Giovanni, you had another question?
What about the acoustic values of Cleancrete?
Yes.
Because often they say we need a concrete for separate one flat to another.
Mm-hmm.
Yeah, you understood, I think.
Yeah. So this is a really, really difficult measurement to do, and we haven't done it yet. But we believe that it will be similar to rammed earth. Like our materials, again, in terms of property, so far is not that far away from rammed earth. In terms of thermal conductivity, the small sample we did was not far away from rammed earth. And we believe that most of the things, property will be close to rammed earth. However, the major difference is how do you process the rammed earth compared to how do you process the Cleancrete. I cannot give you an answer about the acoustic behavior now, but yeah. But me, I have a question here. Is it really, because we are discussing today, is it a really important performance to have, or is it just a nice to have performance so that one knows? I don't know.
Wait, what's the question? I didn't understand the question. Can
like
you
for an architect, for using the product, is it important performance to have? Is it, do you need it in the technical data sheet?
The acoustic performance, you mean, or what?
Yeah. Yes. Let's say if you get around the acoustic properties of concrete, then it's sure an important thing that you can notice.
Okay.
But if it's too complicated, or it goes away from the purpose of Cleancrete, or if you have to add something to get there, so it doesn't make sense. But but if on the way on producing all the things you are now planning to do, you find also that it's a good acoustic value, so say it.
Yeah. Okay.
It's another reason to not use concrete.
Janli, is your question answered?
Me?
You're satisfied? Yeah. Well.
Yeah.
Okay.
Yeah. Exactly.
Then Bärbel Drabel, thank you for your comment in the chat. Your question is answered. I see, and I'm very happy to see Michael Meyer in the chat. And I assume because you turned
long
on
time
video,
no see.
Long time no see, makes it even more nice to see you again. Michael, do you have a question for Janli?
Yes, my question is, have you tried to put plaster or stuff like that on the Cleancrete? I mean, it's not, concrete is used a lot to put plaster on it and paint it, and it does not always have to be on an exposed surface. So is there also a way or experiments you're doing?
That's a good question. We haven't thought of it. We always think that if we look at rammed earth, we try not to plaster it so much because we want to see the material. So we were thinking people will have similar interest to see a Cleancrete, but maybe they won't like it so much, and then we need to plaster it.
No, it's more if you say you want to replace concrete where it's used not for stabilization, but for like a fill between two columns or something like that. Maybe there could be also a way to plaster it. I like the surface, but there are
like indeed. For sure, we haven't tested. One need to check what type of plaster would that need.
Yeah.
Like today, for instance, another question that I was having with Thibaut, my friend, the co-founder, was can you drill or like hang heavy stuff on it, on the wall, right? And maybe we need to think of what kind of drilling things, as you have one for concrete, you have one for wood. Maybe in the future, if the material is widely used, one will have to think of what kind of drilling bolt or whatever it's called you would need to be able to accommodate the formation as you open the door and things like this, or depending on the moisture content, if you kind of have external like expansion of the clay or retraction of the clay, you would need such kind of material. Indeed, like the implementation could trickle down to other new innovation maybe. And thinking here about the plaster, the painting or the plastering, maybe it will be completely different painting plaster than the one you use for concrete.
We have another comment more in the chat.
Yes, I can read out the comment. About your question about acoustic performance, we said that if you want to use the material in housing projects, it's a very important factor. Yeah. Because in housing, it's always about acoustics, even between a bathroom and a living room or in between different apartments. You have to know how much, for the video.
Yeah.
How much how's the acoustic insulation, for example.
Yeah.
It's just to answer your question as a feedback from two architects.
Yeah. No, that's really interesting. I think it's because for us, we don't know, right? We try to assess the performance that we see important. And for material science and engineers, like the static, the shrinkage, the density, the thermal conductivity, done. And then today we were discussing, okay, the moisture buffer capacity, the acoustic behavior, and things like this. I'm not sure if it's really important, but yeah, if you say so, then we have to investigate as well. Thank you very much.
Thank you very much for the question. And I guess we learned today the acoustics is an important factor, and to be able to put a nail into it and hang, I don't know, a painting or a TV or something is an important factor. Jordan, you have another question?
It was related to the acoustic performance. How is the density of the Cleancrete? It's like the concrete.
Yeah, yes. Like the best performing one, the one that will have a 3.7 megapascal is close to concrete.
Yeah. So I think for the acoustic performance, you don't have a problem. You can use this as Unterlagsboden as well, I think.
Yeah. Yeah. Okay, thank you. So maybe it's solved then. We don't need to do that. No, I think we still have to do the test to have a value that proves the, but thank you very much.
Yeah, thank you.
Very good. Flavien from Dresden, would you like to share your comment or your question?
Yes, good evening. Thank you very much. It's really interesting and really impressive. Can you hear me?
Yes.
Yes.
Yeah, for the moisture, I'm thinking about the atmosphere in the room for people using it. How it looks like? Do you have already some tests with some testing with your Cleancrete?
No, we haven't done the moisture absorption. What we have done is the water absorption until it's kind of dissolve, basically. And we have seen that at the beginning you have a high capillary absorption, and but for 1 year, the material still stands, even if you are putting some water in it. And this is something we don't understand quite well yet, why the performance of the material still remain close to what it was when it was first put in water. And then at certain point, everything collapsed. The whole sample just collapsed, as if the water have penetrated all the pores, and all the interaction became completely weak, and then things collapsed. How this associate with the moisture buffer capacity, I don't know yet.
Have you compared it with an earth building or clay and so on? It might be quite similar, isn't it?
Yeah, like clay material from a literature, I know how they be. I have seen their behavior, but often it's completely dissolved right away, and then you see a bubble going up. But in our case, it didn't dissolve right away. It still stand for quite 1 year before having the full collapse of the material. So that's where we don't understand what is the origin.
You have a pretty good attitude.
Okay, thank you. Thank you very much. Yeah.
Thank you very much to our friends from Dresden. We have one more question from Carla Schulte-Fischedick.
Kann ich es auf Deutsch sagen?
Ja.
Genau, also es ging ja eben um die Frage mit den Türöffnungen, wie man das Problem lösen kann mit dem Schwinden, shrinking for the door. And perhaps it could help to get knowledge from the Keramikhandwerk, because they put Schamotte in it to make it less shrinking. Perhaps it could help.
Schamotte.
Schamotte. That is vorgebrannter Ton.
Ah, yeah, indeed.
Perhaps it could help, just as an idea.
Yeah, exactly. Like, yeah, that's a really good idea. We'll try that and see how it performs. What I want to say here is also, like, sorry, it's we understand, like, our core competence is the admixture, and we have little knowledge and concrete like final product and application. And we know that there might be some technical solution that we need to come up with. And we are planning towards this year, like mid of the year, or like around September, to have a workshop where we will ask architects, you have the material with this performance and this constraint, how do you design similar pavilion as I showed you, with door inside, with the floor, with heating and things like that. So I think it will be interesting maybe then to share the call with Hans. Maybe you can forward it to the different people.
Oh, definitely. I mean, I would love to, but I think better thing is you share it yourself in the main chat of Architects for Future Zurich, or also the German chapters of Architects for Future. I'm happy to forward the links to you.
Yeah, please.
I believe it's better when you're direct in contact, right?
Yeah.
So you don't have
So yeah, it will be done. It's now planning, but we will have it in 3 different places in Switzerland, in St. Gallen, in Zurich, and in Geneva, where you will use different earth material from all these different places. And yeah, the goal will be, how do you, considering the different properties of the material and the behavior, how do you make something in a 1 week standing and with less shrinkage, or you accommodate the shrinkage and all the things that we are discussing now. So.
Very nice. Please share the call once it's ready.
Yeah.
In all the, as in the Swiss, but maybe also in the German Architects for Future chats.
Yeah.
Nyanli, I have one question to you.
Yeah.
I mean, thanks so much for your lecture. All the Q&A was absolutely fascinating. But you're here tonight with a lot of people in the, let's say, in the building industry, in architecture. We have been building engineers here. It's a diverse group. And do you want something from us? Like, do you want something from Architects for Future? If you can tell us, what do we have to do to maybe support people like you who are pushing these kind of materials, these kind of technologies? Do you have something that you can tell us what we should do in our work? Like, how can we support you before?
Yeah. Wow. Thank you, Hans. It's yeah, like what I have seen through the past year, like 2019 and 2020, is the power of the architects, how you define the place we live, basically, and the like. I came to believe that you hold the power of like how the society needs to be, the future of the society needs to look like, because you are the one designing our like open area, the one making sure of what type of material to use for which building. So the appearance of the building, the typology of the building, and so I think you are the one who will drive mostly this sustainable change or this path to a more sustainable future. So what you are doing now, I think it's I really enjoy it so much. I told you already, and I think that more and more architects need to realize that the sustainability it's like really important topic. If they are not conscious about it now, maybe it will be the law who will make them start thinking how to change their way of thinking, how to change their way of designing, and so on. And I just hope that from Architecture for Future, more architects come to realize that here's the constraint of our current society, here's the constraint of the material that we'll have to use in the future. Now, how do we build with it, taking into consideration this constraint? It might bring new type of creative ideas, new way of designing, new way of approaching the same problem or different problem. And one might think that it's kind of narrowing down your creativity, but it might open new sort of thinking, a new sort of a creative mind or ideas. So what I could ask is really to continue in bringing architect, engineer, people from the construction industry together, and then sharing them sustainability to most of them. And yeah, we should all act together for a better future.
Thank you so much, Nyanli. I take this answer as an obligation to continue to bring a discussion about sustainability in architecture to more architects, or as in German, Architekturschaffende, yeah? More than just architects. Yeah. All people involved in the architectural process. Nyanli, thank you so much. One last comment. I think what we've seen, Carla, who had a good idea before that might be valuable for Nyanli, I would ask everybody here maybe to leave their contact information and name in the chat. So maybe after you could follow up with one person that you thought was maybe interesting, or you could have a, I don't know, talk to each other and learn from each other.
Yeah. Can I, like, I think it would be good to know what you guys think that Oxara should do as well to make, yeah,
okay,
to still improve our work and our journey. So
okay, but then let's put this question out. I love it. Who wants to answer this question? What should Oxara do?
Yes.
And now you guys have to, Raffi has an answer.
Yeah.
The first thing is continuing to do what you're doing now. And then, of course, you have a lot of inputs from us.
Yeah.
That you have to do, let's say, egg-laying cotton milk pig. Eierlegende Wollmilchsau. It's a thing that can do a lot of stuff, but I think if you keep on doing this with our inputs, I think maybe you even will find something different and better.
Yeah.
So it's keep on doing what you're doing.
Yeah. Thank you.
Basically.
Thank you.
Keep on doing what you're doing. Raffi is very supportive of you, Nyanli. I'm personally also very supportive, but I would still like to ask, are there more answers to Nyanli's question? Who could give Nyanli an answer? Flavien, do you have an answer for Nyanli?
Yeah. Perhaps you could continue to make sure to make this innovation affordable for a lot of people. Like it's out of earth, it's cool. And perhaps the technology is easy enough that it's usable also in a lot of contexts, also where technology is not that much available or other resources. So simple tools and stuff like that. Right? Affordable for as much possible, as much people as possible.
Very good, Flavia. Thank you so much. Michael, what should Nyanli do?
Yeah, maybe it could also be the other way around. It's not that, let's say, social, but as Tesla did, they started with creating kind of for the celebrities and people like that. They drove around with Teslas, and then everybody wanted one. So maybe you implement Cleancrete in some nice old Jati houses, and Kanye West and other people will start to build with it, and then other people want to create with this thing.
Yeah,
I don't know if that's a way, but could be.
Yeah,
very nice.
It's not my personal best way, but
that means, Michael, that Nyanli needs, like Tesla had, this secret master plan.
Yeah, maybe, yeah.
If you Google, I think Tesla secret master plan, that is the explanation of that concept. It's actually quite cool. But thank you, Michael. Anything more Nyanli should do? Oh, Jordan has something. Yes.
Yeah, I have something. Yeah, just continuing like this and try people that it's possible to build with Cleancrete and the other material like straw and clay, and then they will also know that they are alternative to the normal building, standard building.
Yeah, thank you.
I think in a name from everybody, and I've seen in the chat many very nice comments. Would like to thank you a lot for having shared your work, your company's work here with us tonight. It's really inspiring. I'm really
very much.
really excited to see what's going to happen in the next months and years with you and Oxara. Please also check the chat for all the nice comments, I think mostly directed at you. So I think thank you very much to everybody here in the chat. One comment, the next offene Runde from Architects from Future, for Future, is on Tuesday, the 9th of February with Andreas Wicki. We will post it again in the chat. It's going to be about urban climate basics from research and practice. Andreas Wicki, Stadtklima, Grundlagen aus Forschung und Praxis, am Dienstag, 9. Februar, wieder hier in Zoom mit Architects for Future in Zürich. Ich glaube, damit darf ich schließen für heute Abend. Das heißt aber nicht, dass wir jetzt schon alle nach Hause gehen. Ich glaube, wir würden uns sehr freuen, mit so vielen wie euch wie möglich jetzt auch im Zoom uns noch ein bisschen auszutauschen. Sonst eben nochmal, Nyanli, herzlichen Dank und merci, vielmals. Ciao zusammen.